Good day everyone, today we're going to take a look at chapter 7.4 special quadrilaterals. If you take a look right here, you'll see that we already covered the first 3 bullet points and we're now going to take a look at the properties of special quadrilaterals. However, there's only one paragraph after this. There we're going to take a look at corresponding and alternate angles. So this point right here, how to calculate angles in geometric shapes, will also be in order right here. You will see that my explanation of the quadrilaterals that I'm going to talk about is rather theoretical. So then you know the properties of them, right? That's this bullet point. And this one means using your knowledge to now start calculating angles in those shapes. Okay? But first of all, maybe the question where I should start with is, what does the word quadrilateral mean? Do we still know that? What does quadrilateral mean? For all of you who have Latin classes, the word quad in Latin means 4. So maybe then you won't be surprised to know that quadrilateral means a figure with 4 edges and 4 vertices. De Nederlandse vertaling wordt ook al een vierhoek genoemd. Right, so these are all examples of quadrilaterals right here. And some forms we already know the name of, right? We know that this is a square, we know that this is a rectangle. Sometimes we have forms who don't have a special name by itself, for example this one. But we will see that certain quadrilaterals have their own names and properties. So let's start with one. The first one that I want to talk about is the so-called parallelogram. Before I'm going to take a look at what this thing is, one small mistake most people make actually is the translation of parallelogram in Dutch is parallelogram. Dus dat blijft ongeveer hetzelfde. Only the English version has 2 L's and 1 L, and the Dutch translation, or the Dutch word, has 2 L's at both places. That's why I underlined it right here. Just a small mistake that you can easily make. Okay, what actually is parallelogram? I'm going to switch because I am not on my pointer right now, I think. No, I'm on pen. Ah, that's a lot better. Hey, if we have a quadrilateral like this, it has a certain properties. It has eigenschappen. And if we know those properties, we can understand whether something is a parallelogram or not. So, to start with a parallelogram, the opposite sides, de overstaande, hoe heb ik hier hoeken gezegd? Opposite sides. Opposite sides is niet overstaande hoeken, opposite sides is overstaande zijdes. So don't take a look at overstaande hoek here, it's overstaande zijdes. De overstaande zijdes, A, B and CD, are parallel. And BC and AD are also parallel. That's where the word parallelogram also comes from, right? Dus de zijdes lopen evenwijdig. That's one of the properties that a parallelogram always have. So you have the pair of opposite sides that are parallel. En opposite sides betekent overstaande zijdes, niet hoeken. Dat is een fout die ik hier op mijn PowerPoint heb gemaakt. You also have opposite angles, right? That are, for example, angle B and angle D. And angle A opposes angle C. There are quite a few properties that a parallelogram has. For example, a parallelogram has point symmetry, right? I can point rotate it from right here, or I can also mirror it into this line and I find exactly the same figure on the other side. Opposite sides have equal length, so this side has the same length as this one and this side has the same length as this one. They're also parallel. The diagonals divide each other exactly in half. What does that mean? Well, you see the intersection point right here of those lines. This line segment is now equally long to this one. That's why it's also notated like this, right? And this one is equally long to this one. En je kan also say that opposite angles are equal. Dus overstaande hoeken zijn ook gelijk. So this angle right here is equal to this angle, and this angle is equal to that angle. I'm not going to test you on this, so you cannot get a test exercise that says name all the properties of a parallelogram, but sometimes you have to do calculations in a parallelogram, and then using those properties becomes rather important, right? If I, for example, already know this angle right here, I don't have to calculate this one. I can just say, well, this angle equals this one. Why? Parallelogram, or property of a parallelogram. Okay? Just to test you out, I've studied architecture as well, right? So let's take a look at those 4 examples of buildings right here. I'm asking you to find which building would not be a parallelogram. And if you know which one isn't, why isn't it? Give you a few seconds to take a look at this. The correct answer is going to be building 3. Why? In all those buildings, the opposite edges, the overstaande zijdes, are parallel. This one is parallel to this one is parallel to this one, and this one are parallel, and this one, and this one. Here, this pair of edges is parallel, but this one is not parallel to that one. So this building is not a parallelogram for that reason. You can also see that because now this angle here is 90 degrees and this opposite angle right here isn't. So that's also a way that I can know that this is not a parallelogram. And of course those angles here aren't either. Okay, let's take a look at the next special quadrilateral, the rhombus, or in Dutch called de ruit. You could say that a rhombus is a special case of a parallelogram. They say a rhombus is a quadrilateral with 4 equal sides. Dus een ruit is een vierhoek met 4 gelijke zijdes. And you will see that you could say all the properties of a parallelogram also hold for a rhombus, because this here is a rhombus as well. The only difference is that now this side and this side are also equal of length to this side and this side. So you can see right here all the edges, all the sides have the same length. And that gives me a few extra properties as well. Because now the diagonals are also axes of symmetry. Okay, that's nice to know. This one is rather important. The diagonals are now perpendicular. So all the angles here, this one is 90 degrees, but this one as well, this one as well. And of course then this one is also 90 degrees. And the diagonals are now bisector of the angles. That's also a very important property to understand. So this diagonal right here now divides this angle here in 2 equal angles. Here the same way. So that means that this angle is equal to this one, is equal to this one, is equal to this one. And still the whole angle, so without the bisector, dus de hele hoek, als ik de bisectrice wegdenk, deze lijn, is natuurlijk ook nog gelijk aan deze hoek. But now the divided angles are as well. And still all the properties of a parallelogram also hold, right? That's why those whole angles are also equal to each other. I think those 2 bullet points right here are very important when we're going to start calculating in rhombuses sometimes. Okay? So, and this is even a better summary, because now I've mentioned all the properties of a parallelogram. So all those properties also can be applied to rhombuses. Okay? Just to test you on something, this is a question. Every square is a rhombus. Is this true or false? We can talk in riddles like this, right? And then you have to think, well, is the statement true or false? So in Dutch, elk vierkant is ook een ruit. What I would like you to do if you get a question like this is just try to draw a square that is not a rhombus. If you can do that, if you can give me one counter example, als je me één tegenvoorbeeld kan geven, then you are done, because then you say, well, not every square is a rhombus. If you're going to try this, pause the video first and come back if you want to see if you find a square that is not a rhombus. Okay, so now we're going to take a look, well, is this statement true or false? It is going to be true. I don't think you can draw a square which is not a rhombus, because all the properties of a rhombus are also in a square. You can see that this is a square, and all those properties right here also apply. The opposite angles are the same, the bisector divided in two equal angles, the intersection point right here, and the angles that are there, so the angles that come from the diagonals are equal and also 90 degrees. All the edges are the same length and they are also going to be parallel to each other. So yeah, in this case you could say that every square is a rhombus. Dus je kan eigenlijk zeggen dat een vierkant altijd ook een ruit is. Alleen een vierkant is een speciale ruit waarin de hoeken ook nog eens 90 graden zijn. If that also happens, if those angles are also 90 degrees, then you get a square. And last but not least, the trapezium and the kite. Het trapezium en de vlieger. Let's start with a trapezium. A trapezium is something like this. A trapezium is a quadrilateral where at least one pair of opposite sides is parallel. So in this case, SR is parallel to this one, but PS and QR are certainly not right. So, for example, QR could also have been like this, right? So if you go back to the building, which wasn't a parallelogram a few slides ago, that was actually a trapezium form. We also have a special form of a trapezium, that's a so-called isosceles trapezium. Dus een gelijkbenig trapezium. In that case, there is an axis of symmetry. Angle A and angle B are the same, and angle C and D are the same. Also, the plural of trapezium is trapezia. In Nederlands zeg je trapezium en trapezia, kun je ook zeggen. In Nederlands mag je denk ik ook nog gewoon trapeziums zeggen. But in English we say trapezia. Sometimes I have a slip of the tongue, I still call it trapeziums in English as well. I'm very sorry. It is going to be trapezia. If you see me saying this in real life, please correct me. Trapezia. Okay. Also forms, certainly the isosceles trapezium, you sometimes have to use this property right here. That now those angles, if those two angles here are the same, for example, then those two angles here are as well. And last but not least, the kite, the vlieger. Well, we all know the form of a kite, I think, from real life. Well, a kite also has one very nice property. A kite is a quadrilateral where at least one diagonal is an axis of symmetry. So if we take a look at this kite right here, we have two axes of symmetry here. We have PR, now we have two diagonals here. Sorry, we have two diagonals here. PR and QS. One of them is an axis of symmetry and the other one is not. Can you tell me which one is the axis of symmetry? Well, if you remember how an axis of symmetry works, it means that this part of the figure is going to be mirrored and exactly the same to this part, right? So PR is an axis of symmetry. QS isn't, because if I mirror this figure to here, yeah, this is certainly not the same as this one right here. So that's why they say at least one diagonal is an axis of symmetry. Okay, and the properties that you can use here are that PQ and PS are the same lengths, SR and QR are the same lengths, and also Q to this point is the same. I don't know why they didn't name this point here. I would call this T, for example. Then you could say QT is also equal to QR, is equal to ST, is equal to SR. And this angle here in a kite is going to be 90 degrees again. So that was quite a theoretical lesson today. If I can give you a few tips, it's important to know some of those properties, but it's more important for you to be able to apply them, because most exercises in 7.4 are going to ask you to again draw points, draw rhombuses, and sometimes also calculate certain angles. So take a good look. Again, I will elaborate on some exercises on YouTube as well. Take a look at those videos if you still have trouble with some of them. Good luck to you all.